Hey there Codebugs fam, it's VD here with another exciting video on computer vision. As we saw in the previous video, the tech giant Meta released a new object segmentation model named Segment Anything model, that is SAM for short. In that video, we saw the web demo on their official website that showed the capabilities of the model on different prompts and image sources. If you haven't watched it, the link is in the description. Go check it out as we put the model to the test and see if it lives up to its name. In this video, we'll be checking out two things. The first one is that a Google Colab notebook has been released by Roboflow that uses the source code of SAM model to implement it on a bunch of images and extract any and all segments from the images. The second thing is that Roboflow didn't just stop there. They incorporated the SAM model onto their online annotation tool, and we are going to check it out by uploading our own images. So without further ado, let's jump right into it. This is the Google Colab notebook released by Roboflow that uses SAM to generate masks and extract information about each and every segment in the image. It takes a lot of time to run, so I have run this already, and the results are displayed right below every cell. So let's look into it. Here is where the code starts. So here we are defining our home just so that we don't get lost. And here is where we are installing the Git repository. This is called Git Repository cloning, and the repository is also given on the official website. If you go to the website, you can find the GitHub icon here, and you click that, you will be redirected to this GitHub repository. And this contains all the source code that you need for implementing SAM. And this is the code to clone that particular repository. And if you move down, here is where we are downloading the weights. A weights file is basically the model trained on a particular data set, and it has a .pth extension, and that is how you can identify it. There are a lot of models that SAM released, and here we are particularly using SAM _VIT_H. This is the model that we are going to be using. So the next thing that we are doing is we are going to download some example data for which we are going to do the segmentation on. And you can just copy this link and paste it on an empty tab, and you will get the image. So this is the image that we will be working on. The next cell represents how to load your model. So you import the torch model in Python, and you create this variable called device that contains all the device information. That here it is the Google Colab GPU. If you are doing this from a Jupyter notebook or something, it would be your local runtime. And the model type is VITH. So segment anything is the Python model that contains all the necessary functions and variables that we need to run SAM. Even though we have the weights, we need proper functions to run the weights onto the image, create a image with the masks, and to plot those images on our Jupyter notebook or our Google Colab as well. So the first thing that we'll be doing is import the segment anything, and you can import segment anything the whole module, or you can just import these three sub modules that we are going to be using in the next code. So what we are trying to do here is to run an automatic mask generation. So to provide a SAM model to this particular class, we need to set the path below to SAM's checkpoint, right? And since we are running on Coda, the default mode is recommended. Yes, we are not changing anything regarding that. So the mask generator is the automatic mask generator that we need, and this is the class, and this is the constructor that we're giving, and we are loading the image here. And this is the part where we are starting to create the masks. So first we need CV2 computer vision module, obviously, and the next thing is supervision. Supervision is basically used to plot the said image plot the said masks onto the image, because whenever we are using SAM in a code structure, the results that we get will be numeric and will be an NumPy array, right? All images in computer vision are represented as NumPy arrays, and since we cannot visualize the array as a picture, we need a module that will help us plot those images, and supervision is one such module. And in this cell we are loading the image, and we are calling the mask generator.generate function to generate the masks on this particular image. And this SAM result will have a particular output, right? So that is explained in this particular cell. So segmentation will be np.ndarray, so that is a numpy array with the mask that is having a shape of w, h, that is the width and the height of the initial picture, and bool type. So what basically this segmentation returns is that we will know whether each pixel is a part of that particular mask or not. So if the pixel is a part of the mask, it will be included in the mask, and if it is not, then it will be a 0 or a false, right? So that is bool. It is either a true or a false. True means that pixel belongs to the part of the mask. False represents that it does not belong to the part of the mask. And why do we need this distinction is because if we are going to represent the mask in a different color than other parts of the picture, then this will come in handy. For example, if I have the dog picture that we just saw, right? So we'll go to the dog picture. If we want to segment only the dog, and I know, for example, this particular pixel right here, right? So this pixel is a part of the dog. So there my value for that the boolean value will be true, and when the boolean value is true, I will color that part of the image, right? So then I will have a mask all over the dog. So this is the basic idea behind masking images, and why we are using a numpy array with the bool data type. And for each mask we have the area, so that will be the area of the mask in terms of pixels, and b box stands for nothing but the bounding box, and the predicted IOU is the model zone prediction for the quality of the mask. Yes, these are things that we don't need, but it evaluates the model's accuracy. So SAM result is basically a dictionary that contains a lot of keys and values, and here is the keys that we are going to be getting, and each key is explained here. So in this cell is where we are actually applying the masks, right? So we have the numerical data of where the masks are and what pixel that is, how much area that is, and the bounding box details and everything. Now what we have to do is plot those values onto the image so that we get a segmented image right here, right? So this is the code that does that. So we have the mask annotator, and we are annotating the image. And so first we need to initialize that mask annotator, that is supervision.mask annotator. So we already have the masks, and all we need is supervision to annotate the masks on the image. So that is what we are doing. So we have the detections, and the annotated image is basically placing those masks over the already existing source image, and we are plotting both together side by side. So images will be image BGR, which is the actual image, and annotated image, which is the result of using this mask annotator, right? So, and this is the grid size, and the title is source image and segmented image, which is exactly what we're seeing here. This is the source image, and this is the segmented image. So the next thing we'll be seeing is how do you interact with the segmentation results, right? So this can't be the only way that you can use the segmentation results. There are multiple ways in which you can use it for each use case that you're going to be doing. And this is one such implementation. So we have the masks, and now what we're doing is we are plotting the masks against a black background, and each mask will be separate from every other mask. In this example, we are plotting all the masks together and differentiating them by color, but here we are going to take each and every mask and plot them separately in a black background, right? So whatever is white is the mask, and this is one segment, and this probably represents the sky, and this probably represents the person's backpack, and this is the dog, and this is the person's shirt, and this is the sling bag, right? So I hope you get the point of like how we can use this to display it in different formats. So basically there is no difference between this and this except the way that we are representing it. And moving on, we will be looking at some other use cases of how to use this. So this is one such prompt in which we are going to be giving to the SAM for it to isolate the places where it is going to segment, right? So in the previous example, we were segmenting each and everything in the image. Now we are going to have a bounding box that we can move around, right? So if you place it near the dog, right, so only the dog is there inside this bounding box. That is the major segment here. So that is what we should be getting as the result. So this is something that we have already seen in the previous video in the web demo. So yes, as you can see, this is the source image with the bounding box, and inside the bounding box there is this dog segment alone, right? So this is one way that you can isolate a particular segment. And this is in representing it on the image itself, and this is doing the same in black and white. And the next thing would be to use Roboflow dataset, right? So we're going to download a particular dataset from Roboflow, and that is the MRI brain tumor dataset. And what we're going to do is use the functionality that we saw above. That is, if we have a bounding box, we can segment the object inside that bounding box, right? So we are going to use that in an MRI brain tumor dataset. So this will be the result, right? So we have the source image, and obviously we have the detection here. So this is the data set already has all this information about where is this particular brain tumor. So once you put a bounding box around it and then you give it to SAM, now SAM knows exactly what is that segment inside that particular bounding box, and here we have the exact shape of that brain tumor. This is a very interesting application, as SAM is going to be very useful in medical AI, correct? So that said, we've reached the end of this Google Colab, and I hope we understood the different usages of SAM in different scenarios, right? And this is not only limited to Google Colab, you can actually do this in your local system, but make sure you have enough RAM and VRAM to run this, because this takes a lot of computational power to run. And it is one of the reasons why I am doing it in Google Colab and not in my local systems as well, because it takes a lot of time and computational power. So that is the first part of the video. So without further ado, we'll move to the second part. We will go check out Roboflow, right? How they've implemented SAM into their annotation tool, right? So this is the blog that they've written about it, and this is the YouTube video they've released about it. But we're not going to read the blog, we're going to jump right in and start using the tool. So go to Roboflow, sign in, and if you don't have a workspace as such, you can always create one using this create new project and create workspace here, right? So I have a workspace named segment anything model demo, and inside which I have SAM demo as a project, and I already have one image annotated, but let me start from scratch. So I'm going to upload one particular image, right? Let me show you that image, save and continue. Let me upload it first. So we are going to use a particular tool that Roboflow already has this, but that wasn't as efficient because it was using other segmentation models. And because SAM is actually awesome, they have introduced SAM in the backend to interact with your image and create segmentations with just a click, right? So I'm going to start annotating, and this is the image, right? So we have the image right here, and we have these tools on the right. We have the drag tool, the bounding box, and the polygon tool. So this polygon tool is the basis for any and all segmentation that we generally do, right? So for example, as you can see in the example video, they are creating a polygon around that strawberry, and that is the segmented part. The mask will be created around that, right? So this is, as you can see, a very tedious process, and here is where SAM comes in, right? So we have this new tool called Smart Polygon, right? So I'll click this, and I don't want the enhanced. Standard is fine. And as I move inside, I can actually click on a particular object. For example, let me click on this person's jacket. As you can see, the moment I start hovering around the image, I am able to see multiple segments, exactly as how we saw in the demo for Sam, right? So yes, now I'm able to isolate this jacket alone. I will click on this, so I can name whatever I want to here, right? So I can save this also, right? So this will be one particular segment. So yeah, this jacket will be, if I'm going to be creating a jacket detecting or jacket segmenting model, so what I'll basically do is I'll just click on the smart polygon, and I'll just go to any jacket or shirt or something, and then I'll click on it, right? And then once I click on it, I'll just save it with that particular name, and now I have a class that is right now it's segments, and I can rename it towards jackets or whatever. So yes, so this makes data annotation so much easy as compared to how it was before. Let me use the polygon tool, right? So for example, if I have to, let's say, let me zoom in. So if I have to, let's say, segment this particular shirt, right? So first I will have to just finish this. Yeah, so first I will have to click one by one, right? So this is a very tedious process, as you can see, right? I have so many endpoints, and obviously they cannot be that accurate, right? So I will have to increase the amount of corners that I'm going to be having if I need to be extremely accurate, and this is going to take a lot of time. But if I do the same thing using smart polygon, it's gonna take a lot less time, right? And there it is. So I'm gonna click enter, and here we have the segment, right? As I zoom out, we have two segments here. We have this and we have this. So this is going to change the way we create data set and the way we see annotation as a job as well. So this is going to make it so easy to create new data sets, which consequently will create better, detection models and segmentation models, right? And that's a wrap for today's video on the segment anything model, or SAM for short. I hope you found this demonstration informative and useful. If you have any questions or comments, be sure to leave them down below, and don't forget to like and subscribe for more computer vision content. Until next time, keep crushing it in CV, and I'll see you in the next video. Thank you so much for watching.